Now another way to make alkyl halides, but this time we're going to start from a alcohol. And when we treat this now with HX, so an acid, we will generate our alkyl halide. As before, the X here has to be chlorine, bromine, or iodine. Okay. And the alcohol is going to determine what type of mechanism that we are going to invoke. So let's start off with the primary alcohol, like so, ethanol, and we treat it with HBr, like so. What's the first step in this reaction? This is going to be a proton transfer because HBr is an acid. And our alcohol here is electron rich. So that's going to protonate our alcohol like so. And then it will generate Br minus. And then to generate our alkyl halide, we would have to invoke another step here. And since this leaving group is attached to a primary carbon, it can't just leave by heterolysis. If it left by heterolysis, what species would you generate? You would generate a primary carbocation if this group just left. It doesn't do that because that primary carbocation is so unstable. But it does undergo a SN2 style. And so this lone pair here, we could grab that one if we want and attach that carbon and then kicks off the leaving group to generate 1, 2, Br, and then what fell off? Water. And there you go. We have generated our alkyl halide. But if we change what the alcohol looks like, things are going to be a little bit different. What if we had a tertiary alcohol? And we treat that with, let's say, HCl. The first step is going to be the same as above, that we will have a proton transfer, like so. That will generate a good leaving group. And we have our chloride floating around. Let's make sure we have our lone pairs there. All right. Now, can we invoke a SN2 style mechanism here? Can this just come in and kick off the leaving group? No, because the leaving group is attached to a tertiary carbon. So what's going to be the next step? We're going to have a heterolysis step. And so that means the leaving group just leaves. And when it leaves, we generate a tertiary carbocation plus what left, which is water. All right. And now we can do the next step, which is the coordination step. I'm going to run out of room here. Coordination step. And so what do we have? We have chloride floating around. So that chloride then can come in like that to generate our product, which will look like this. So this reaction in green here, we have all these steps: proton, heterolysis, coordination. What can we call all three of those combined? An SN1 mechanism. So when you're doing when you want to make an alkyl halide from an alcohol, the mechanism can be SN2 or SN1, depending on the type of alcohol that you start with.